God bless you. Starting with the median, which is the coolest one, and I'm going to show you a little illustration of why in just a second. When you draw a median, what you're drawing, thank you, ma'am, is a segment that joins a vertex to the midpoint of the opposite side. Okay, so notice this is a midpoint because those are marked congruent. And then that point is getting connected to the opposite vertex. So your median is that line. Okay, it's a midpoint connected to the opposite vertex. Now the super cool thing about the centroid of a triangle is this. I made myself a triangle out of cardstock. And then what I did was I took a ruler and I measured this side. I cut that number in half. I put a little mark there. And then I took a ruler and I connected it to the vertex. And then I did the same thing on this side. I measured it, I cut it in half, and I connected that with a ruler to the opposite vertex. Why do I not need a third one to find the centroid? Yeah. Right. Well, wherever these meet is where that third one's going to meet too, right? If you did it right. So I only found two, but if I had done the third one, that would go here and it would pass through that same point. Okay. So this point right here on this triangle is the centroid of this triangle. Okay. Here's how a centroid works. It is super cool. It is the center of gravity of a triangle. So if you take a triangle, it doesn't work with regular paper because paper is just too loosey-goosey, and you have to kind of make it a big triangle for it to, oh, loosey-goosey. Was that you? Were you enjoying your name there? Do people call you that?
That's what my parents and my
Do they really?
family.
That's cute. Okay, anyway, when you do it with a big enough triangle in cardstock, you find the center of gravity of the triangle, and then you can do this. We'll see if it works. This doesn't always work. It worked in my last class, though. So if you put your pinpoint on that point, oh dear. It's the center of gravity, you guys. How cool is that? Math is cool. I love math. So that's the most interesting thing, I would say, about a centroid. But then there's something else that comes into play with centroids that's a little more like what you're going to use it for. So let me tell you. First of all, the three medians get you the centroid. Okay. So in this picture, name a median for me. P is a centroid. What's a median? F what? FB. Okay, so this is one median. AE is another one. And DC is the last one. Okay, so where those meet up is your centroid, which is point P here. Okay, and then here's the cool thing about centroids. The medians, when they all meet, break your segments into proportional pieces. So what happens is, I'm just going to give you the relationship in equation form here. For instance, AP, so this piece right here, will equal double the other side, PE. So if you double the shorter part of the segment, you will get the longer part of the segment. Okay? Which creates another relationship. I could say that PE is half of what? AP. Okay, so you can do it either way. If you know the smaller one, you would double it. If you know the bigger one, you would cut it in half. Okay? But then there's another relationship that I think is why sometimes it's tricky to figure out what length everything is, because while they're the same, they're different. So it can be a little bit tricky. Here's the big picture. This piece, AP, is some fraction of AE. Does anyone know what fraction of AE it is, knowing what we know up here? 2/3. Brilliant. If this is, let's think of it this way. This is X, right? Then this piece would be X and that piece would be X. So if those are 3 equal pieces, if I were to put a little hash mark there, that is 2 of the 3 equal parts, right? It is 2/3 of the segment. So AP is 2/3 of AE. So what does that mean for PE? What fraction is PE? 1/3. PE is 1/3 of the whole thing. Okay, so I'm going to show this to you multiple ways because sometimes you're going to know the whole thing and have to find the parts. And sometimes you're going to have to know a little part and find the other 2 parts. And sometimes you're going to know the bigger part and have to find the other 2 parts. And you do it different depending on what you know. Okay, so first of all, number 1 is none of that. Let's look at what we know for number 1. JK is 22. KN is 13. And OL is 18. Now, if this is a centroid, which they tell us it is, what do you know about the sides of the triangle? What's happening to them? What is this point? It's a bisector. It's a midpoint, okay? Because a median is always a midpoint connected to a vertex. So that means JO is what? 18. Yep. What is NL? 13. Okay. So what is KM? 11. And then JM, also 11. Okay. So if you come over here, you can fill in those blanks. KM is 11. NL is 13. KL is 26 then. Add those 2 together. JO is 18. And JL would be 36. To double your 18 or 18 plus 18. Okay, so we know side lengths because we've got midpoints. But what if they start using those segments themselves? It says if Z is the centroid, okay, so this is a centroid, I would label what you know. So TZ is 60. XZ is 28. And WZ is 25. So they ask you for ZV first. What fraction of the segment is ZV? Is it half? Is it 2/3? Is it 1/3? What is it? ZV. It's the 2/3 portion of the segment, okay? So if that is 2/3 of the segment, then what is 28? Which fraction of the segment? That's 1/3 of the segment. So this is a third. This should be 2/3. So how do you go from 1/3 to 2/3? What do you do to that number? You multiply by 2, right? You double it. 1/3 doubled is 2/3. So you're going to take that 28 and double it, and you get 56. So ZV is 56. Okay. Then they ask about ZY. Which fraction of the segment is ZY? That's the 1/3 chunk. Okay. The one that goes to the vertex is always the 2/3. The one that goes to the side is always the 1/3. But you should be able to tell, like, one looks longer than the other, right? One is half the length, one is double the length. So if this is 60, what is DY? What do you do to 60? Cut it in half. So ZY is 30. Okay. So what is ZU? That's the 2/3 chunk. So if the 1/3 is 25, then what's 2/3? Double it, 50. Okay. So what is TY, this whole thing? It's 90 because the smaller chunk was 30. So 60 plus 30 is 90. And then what's XV? 84. Okay, add those two pieces together. Okay, so that's if you know a fraction, right? One piece of it or the other piece of it. But what if you know the whole thing? Well, if you come down here and they tell you that TU, okay, TU is 27. If the whole thing is 27, then what do I have to do to find XU? Daniel? Divide by 3 or multiply by 1/3, right? It is the 1/3 part of the thing. So if you have 27 for the whole length, you can cut it into thirds, right? 27 divided by 3. That means the shorter one, the 1/3 chunk, should be 9. So that's XU. What's the 2/3 chunk then? 18. You double the 1/3 chunk, okay? So your options are multiply the whole thing by 1/3, but really what that's doing is dividing by 3. Okay, so you can multiply by 1/3 or you can divide by 3. You're going to get the same thing. So XT is 18. Let's see. They told us RV is 21. This length here is 21. What is XV going to be? That's the 1/3 part, right? If the whole thing is 21, what's XV? 7. 21 divided by 3, right? Cut it into thirds, so this would be 7. So what would RX be? 14. So RX is 14. Okay. What did they tell you? SW. This whole thing, they said, is 18. So 18 divided by 3 would be 6 for the shorter chunk, which means 12 for the bigger chunk. So this one's 12. This one is 6. Okay, so if you know the whole thing, you're dividing by 3. If you know one of the parts, you're either cutting it in half to get the other part or you're doubling it to get the bigger part. Does that make sense? Okay, so that's what the centroids do. You're going to skip this entire page, flip to the next page where it talks about altitudes. So with an altitude, sorry, I mixed up my order here. An altitude is always like the height of the triangle. Remember back in the day when you found the area of a triangle, okay? That was the base times the height, right? So altitude is the height of the triangle. It will always be perpendicular. So it's always going to be joining a vertex to the opposite side that it is perpendicular to. Okay, so this right here is an altitude, this line. Okay, now altitudes can fall in different places depending on what type of triangle you're working with. So if it's an acute triangle, your height, your altitude would be inside of the triangle. Okay, so sometimes it's inside the triangle, but it can also be outside. When it's an obtuse triangle, if I want to go perpendicular to this side, but through a vertex, the vertex I have to go through then is this guy. If I'm going to go perpendicular, it's going to look like this. So you kind of have to extend that side, and now your altitude is outside of the triangle. Okay, when is it on the triangle? What type of triangle? A right triangle, because you have a 90-degree angle. So this could be your altitude, or you could use this one as your altitude. It just has to be perpendicular to a side, okay? So keep in mind, when perpendiculars show up, what shows up a lot if you're looking for side length? You did it a couple days ago. What? It's a right angle. What shows up a lot with right angles when you're trying to find side lengths? not a bisector. What shows up a lot? The Pythagorean theorem, okay? So when you're working with altitudes, you're probably working with the Pythagorean theorem. So look for it. It's going to be there, okay? So this says the three altitudes of a triangle intersect to find the orthocenter, okay? So in this picture, what are your altitudes? Perpendicular and through a vertex. Give me one altitude. FB would be one. What's another one?
CD.
What? CD would be one. And the last one? AE. Yep. So your orthocenter then is point P. The point where they all meet up is your orthocenter. Okay, and like I said, look for the Pythagorean theorem on these. I think it's question number 7 in the homework. If you want, I can actually walk you through part of that. But you'll be doing the Pythagorean theorem, okay? Oh, unloading in the rain. That's no fun. Okay, so quick review. Here's the things we've done. Number 1, the circumcenter is created by the intersection of 3 what? Perpendicular bisectors. Okay, the incenter is created by 3 angle bisectors. The centroid is created by 3 medians meeting up. And then the orthocenter is 3 altitudes. Okay, so those are the 4 points of concurrency that we found. Those are the only 4 that we're going to work with. They're the only 4 that exist. But then let's talk about these 2. 2 of those had special equidistant parts to them. What one created things that were equidistant from the vertices? That was the circumcenter. When we found all the perpendicular bisectors, then the circumcenter was equidistant from the vertices. Which one was equidistant from the sides? That was if you found an incenter. That was the angle bisectors that got you the same distance from the sides, okay? If you want to help yourself remember these, Pomasico is a good tool for that, right? P being perpendicular bisectors get you circumcenter, angle bisector incenter, median centroid, altitude orthocenter. Pomasico. Any questions on that?